Okay, we are recording. Welcome, everybody. This is a recording in which I'm going to talk about course organization, some logistics, and advice on how to do well in this course. What's this course about? Fundamental underlying philosophies of the course, stuff like that. Okay. All right. So let's dive. Oh, by the way, of course, this is for Math 219, summer term 1, 2025. And I'm Clark Bray. I'm the course instructor. Let's just dive on in. So real quick first, if you're thinking about being a math major, come talk to me. No big deal. Nothing urgent, but I think it's a natural thing to do to check in with your instructor, of your major, especially in, early on in the major, as I would imagine any of you all who are math majors, likely are. Just to make sure everything's in order, make sure you're on the right track, stuff like that. Again, at your leisure, no big deal. Okay, so moving along, let's talk about the class website. Here is the link for it. I probably have already shared this link with you in the email from which you were notified of the existence of this recording. So my best guess is you probably already have this, but anyway, just in case, there it is. So that is the class website. There is also something called a course website. Now I put here shared. There is in fact only one section of Math 219 this summer. So we're not sharing with anyone. Even though it's not shared, I still keep these two websites separate, partly just for kind of logistical convenience, but also to distinguish between things that are specific to how I teach the course versus things that I see as being about the course overall. That should apply to all offerings of the course. Okay, alrighty. So anyway, the first thing to do, think of this as your first homework assignment, is to read all of that. So the class website and the course website, which again is linked from the above class website. All right, so it's a lot to read. There's a lot to say. How I teach a course and, how to do well and blah, blah, blah. There's a lot to it. So, anyway, make sure to read all that. You don't have to memorize it, but, I do think you should read it and understand and, kind of know where to go, to get information, particular details when you might need them. Okay. And then, also click around on the links there, again, just so you know what's where and, for, easy future navigation. Okay. Real quick, let's just go to it. Here it is. This is that, course website, class website. And then, here's the link to the course website, which you need to click on as well. And, there it is. Okay. And there's a lot of good information here, and we're going to go through what's on this site. We're not going to go through all of it, but we're going to go through some of it as outlined back here on my little outline page. Okay, so the first thing I want to talk about, course operations, the content syllabus is an important thing. This is what's in the course. What are we doing? What are we going to talk about in this course? It also shows what homework exercises are going to be assigned, and furthermore, some other homework information, information about content. So let's go to it and see it. Here you go, content syllabus. Notice Bray's reordering. I have the topics ordered here in the exact order that I will be covering them in class. So we're going to start with section 1.1, move on to 1.2, et cetera, et cetera. Notice they are not all in order. I like to do section 3.1 before we do section 2.5, and that's because my take on the chain rule makes use of the ideas that are covered in this section talking about parametrized curves. So this little reshuffling I think is convenient. You'll also notice something happened here. There is no chapter 4. Where did chapter 4 go? I moved chapter 4 all the way down to the end. And there are good reasons for this. Ultimately, the reasons are that chapters 6 and 7 are that's the most challenging material in the course, the stuff that you need the most time to digest. And so basically, there's quite a bit of value in being able to delay topics until after that. I don't want to say too strongly, but case can be made anyway. Any material that is not prerequisite to chapters 6 and 7 arguably should come after chapters 6 and 7. That'll give you more time to digest the ideas of chapters 6 and 7. This stuff here in chapter 4 is it's relatively straightforward. Okay. All right, so you see the topics covered and what order we'll be doing them. You'll also see, as we discussed, exercises, right? So for example, when we finish section 1.4 on the cross product, these are the homework exercises that will be assigned. So specifically those are the ones you have to complete and turn in, and we'll talk about the logistics of turning in a minute. Okay. Real quick, all of these exercises are from the book, and which I hope you all have a copy of. Here it is, textbook. Colley's book, Vector Calculus, 4th edition. Let's see here. The exception is that there are some exercises you'll see labeled AHP. And AHP stands for Additional Homework Problems, which is a PDF file that you will find in the course materials section of the course website. Okay. All righty. Okay, so, let's see here. While we're here, I'll point out a couple of other things to say. In section 1.4, for example, arbitrarily, you'll notice in this column here, excluded material. There's an entry, this right here. So this is part of section 1.4. It is in the book, but it is not part of the course, and you're not responsible for reading that. The reason that we have stuff like that is that, this book was not written specifically and exactly for Math 219, right? This book that we're using was written for sort of generic purposes, and target audience was not tailored to this course exactly. My feeling is that, and by the way, let me just go ahead and say I think this is an excellent book. I like it very much. I have my little quibbles I'll probably point out as we go through the course. But it's overall, I think, an excellent book. But I do think it's aimed a little bit higher than Math 219 is. So again, there are going to be a few instances of stuff you're not responsible for. So keep an eye on this column, the excluded material column, and don't spend your time when we get into section 1.4. Don't spend a bunch of time looking at proofs of properties of cross product in the book, because it is not part of the course. Okay, while we're here again, notice there's also this included material. Included material column. This is stuff that's not in the book, but that is part of the course. And all of this stuff will be covered in lectures. So you'll see, for example, in the section on the chain rule, the book does not have any discussion of second derivatives with the chain rule. And there's some very important and a little tricky, unless you look at it just the right way, issues that come up when you do second derivatives involving compositions of functions and using the chain rule. And so I think that's really important. And this course does include that material. That is part of the course. It is fair game. You do have to know it. But it's not in the book. Right, so I have put it in this column. It's going to be covered in the lectures. You'll also find it in the lecture notes, which we'll talk about in a minute. And likewise, implicit differentiation and blah, 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 a few other things down here. Okay. All right. Oh, I skipped over the stuff at the top. Make sure to read all of this. It's all very important. In particular, some explanations of stuff we just talked about. And then in particular, there's discussion here of prerequisites for the course. So there's actually a lot of prerequisites for this course, what we call the prerequisite trail. And the listed explicit prerequisite just says linear algebra, but linear algebra assumes you're proficient with single variable calculus. Single variable calculus assumes that you're proficient with various high school math topics. All of that will be assumed. Math, at least this math class, is very vertical. It builds on ideas that were built on ideas that were built on. It's like a multi-story building in that sense. So vertical, as I like to say it. So it's the nature of the beast, and so make sure you're good, make sure you're polished and proficient with all of that prerequisite stuff. So I list some specific topics. A lot of students in particular, maybe they know linear transformations, but they maybe forgot how they relate to matrices. And what I see a lot of is what I'm going to call standard geometric examples of geometric operations that are linear transformations and how to understand them with matrices. So this is something I do think is very important in this course, and so you want to make sure you're good with that. Now, I am going to talk about this stuff in class a little bit. It's going to happen when we get to section 1.6, but it will be pretty terse, right? So I am going to assume that you mostly understand linear transformations in particular. I'm going to mostly assume that you're comfortable with the relationship with matrices, and then we'll talk about how you can use that to understand these standard geometric examples. Okay, and make sure to read all the rest of this stuff, of course. Okay, back to let's see here, back arrow. Okay, and back to my organization. Okay, so we talked about the content syllabus. Done. We'll move on now to the class schedule. Where to find the class schedule? Well, also on the website, specifically the class website. So here it is, class schedule. Boom. So this basically shows everything that you need to know about what's going to happen in pretty much every day of the class. And there's a lot to say here. So let's see here. There's a bunch of stuff to read. Make sure to read all this. I'm going to talk through some of it, but do make sure to read. Again, details matter, so read all that stuff. And then we'll just kind of look at what we've got in the sheet here. You can see for every class meeting, there's sort of a number. So the first Monday of class, May 19th. That's our fourth class meeting. You can see that my goal, we'll see if this happens, my goal is to be done with page 48 of my lecture notes. That's my target, my goal, right, is to be done with page 48 of my lecture notes by the end of that first Monday. Well, it's possible, might be able to do that. Again, I have an aggressive start built up. Well, okay, I can't really highlight like that, but this column here indicating my target, you'll notice that my goals of how many pages to cover, roughly 13 pages a day. Well, okay, and then eventually more like 11 at the first of the course, and then notice near the end, significantly fewer pages per day. So I do that because this material at the beginning, in these first, pages of the notes, is relatively easy material, and it's just not an effective, efficient idea to spend a bunch of time going slowly through easy material, and then to not be able to go slowly at the end of the course through the harder material. So, roughly speaking, this is an optimization problem, and this is my current take on how I think to sort of optimize the presentations in the course. Okay, so anyway, you can use this as a guide for, when you're preparing for class, trying to decide, what should I read in advance, which I think is a good idea, by the way. We'll talk about that more later. But how much in the lecture notes do I need to read ahead? You can speculate reasonably based on these targets. As we go through the course, I'll be filling in these entries here in the actual column. So if we only get to page 10, for example, on the first day, then here in that spot, I'll put a 10, and then you can speculate and say, okay, well, we're 3 pages behind, so we're probably not going to get to page 26. Maybe we'll only get to page 23. And that would be a reasonable speculation when you're, again, doing your pre-lecture prep. Okay, so let's talk about homeworks. Roughly speaking, homework's going to be assigned every day. Every class meeting, homework is going to be assigned. This class moves so fast. We're covering 15 weeks of material in a mere 6 weeks. All right, so this is blindingly fast. If I were to collect homework assignments into, weekly, maybe have the first homework assignment not assigned until this day here, and then maybe have it due here, we would have one homework assignment completed before the first exam. Come on, that's not a good. Where the homework would not be keeping up with the course. Right? Just doesn't work. So we're going to have homework assigned every day. Pretty much what's going to happen is, again, on this day, in my hopes to get that much done, whatever I actually get done, I'll look and see how many sections of the book, which specific sections of the book we will have finished by then, and I will replace this right here with an indication of which sections from the content syllabus we have finished with and are therefore assigned. And of course, which exercises do you have to do from those sections? Well, those listed on the content syllabus. Okay, so homework 1 will be assigned on that day, that Wednesday. It'll include all the content syllabus exercises from that section, and it'll be due on this indicated date here. So likewise, for all the other assignments, you'll notice as we go down, there's a indicated due date for every homework assignment. They mostly follow what I'm going to call kind of a 2-day pattern. So, for example, this one, homework assignment number 1, on Wednesday is when you come to class, hopefully having studied the material, the lecture notes, the book, somewhat in advance. You come to class, hopefully learn it more. You leave class, you study that some more, hopefully fill in all the blanks. You start on the exercises, do as much as you can. This is all on the same day. It's a super busy job taking a summer math class. And then, you might not finish, right? So the next day, Thursday, that's not what I wanted to do. The next day, Thursday, whatever you couldn't get done, whatever you didn't understand, whatever you need some help with, you come to office hours, you talk with classmates, you go to the we don't have a help room operating this summer, but so we will have office hours, mine, and hopefully also a TA office hours, and you get the help you need, you understand how to do those exercises, and then Thursday night, right, as indicated by the due date, Thursday night you submit the homework, and notice as it indicates here, all homework due, that kind of conceals it, doesn't it? Anyway, 11 p.m. Eastern Time, Durham time, is the time that homework is due. Okay, so that gives you, in some sense, 2 days, right? So much, anyway, of Wednesday, and then all of Thursday, practically all of Thursday, to get that submitted. Okay. All right. So yeah, you'll notice most of them follow this pattern, right? Thursday, due on Friday. Friday, due on Monday, et cetera, et cetera. Weekends don't count. But there are some that are a little different. These are related to, usually in relation to holidays and exams. So again, holidays don't count. You would expect, perhaps, for this Thursday assignment to be due Friday. Why is it due Monday? And the reason is, you'll notice with the coloring, what gets covered on that Thursday, colored green, is the last material that's fair game for exam 1. And it seems reasonable to me to give y'all the additional flexibility since these exercises are part of your preparation for exam 1. Why not let you turn it in just before, effectively, exam 1. Okay. All right. So anyway, there's a couple of little schedule hiccups here. I've highlighted those in red just to make them obvious. Make sure not to forget to check those. You're always going to keep an eye out for that. A couple other little hiccups. You can see homework 8 here in particular. Well, that doesn't highlight well. But homework 8, I'm actually doing 2 lectures worth of stuff. And again, it's because of sort of schedule considerations. This stuff here, for example, the stuff that we cover on Friday, that's the Friday before the exam. But that material isn't fair game? Are you really going to start on that? Right? And so I'm going to say, nah, come on, you're probably not. You probably shouldn't, right? You should probably be spending that time focused on preparing for the exam. So even though we cover this material on Friday, I'm viewing it effectively as kind of Tuesday material, and Tuesday material, naturally, do Wednesday. Okay. All right, one other thing I need to talk about. It might look a little confusing here. You can see for Tuesday, we have an exam listed, and yet I also am expecting to cover material on that same day. So what's going on there? The answer is you got to keep in mind these summer class meetings. These summer class meetings are 75-minute meetings. And I think 50 minutes is reasonable for an exam, certainly semester classes. My midterms are all 50-minute exams. So on exam day, the first 50 minutes of the exam day will be the exam. And then after that, when the exam's over, we'll collect the papers, and we've got 25 minutes left, or thereabouts. Might end up being only 20, but we've got some valuable minutes left, and we're going to use that to cover material and hopefully, possibly anyway, finish something. Okay. All right. So that'll be how we're gonna do that. Now I'll say more about that stuff, probably in the few days before the exam. Okay, moving right along. Notice that there's this column over here of comments and reminders. There's little bits of advice and observations and that sort of thing that makes sense to be noted at particular times through the term. And so that's what this column is for. And so, for example, you'll notice first day of class, it's a good time to remind students you need to start working on the exercises that same day, et cetera, et cetera. This one, I like to remind students, you might not believe it, term just started, but there's an exam coming up. We've got an exam in just 1 week. You can see it here on the schedule, right? Tuesday, May 20th. Yep, there is an exam on Tuesday, May 27th. It's coming up. And so little reminders, little bits of advice, stuff like that, little explanatory comments. And so you see throughout the term, I have some of these comments included here. Okay. All righty. Let's see. Oh, last thing, and this is just kind of for fun, but I have found that I typically get to class early. I like to set up my computer, see if there's any technical problems, glitches with the classroom system, which sometimes happens. And so on the days when everything is fine, I'm therefore in class a little early. We've got some time, and the projector system has speakers, and I have a Spotify account. And so I think it makes sense to listen to some music. So I've put together various playlists of music that I personally like. Stuff that's important to me, and that that I think it is good for students to be exposed to. So it's not, look, I know that everybody has their musical tastes and everything, right? But, y'all are probably more up to speed on current music, and you might be less up to speed on older music. So a lot of this is older kind of music. There's some sort of rock and pop in here. There's blues as one of my favorite kinds of music, and jazz is a beautiful thing. And so anyway, all of these playlists are things that I just want to make sure everybody's been exposed to at least a little bit. You don't have to take it serious. It's not on the test, but it's just a little atmosphere. And if you might be struck by any of the music that you hear, and if you'd like to know where to hear more, these references here will tell you how to track down, hey, what is that? How can I find more of it? Okay. All right. Okay, so let's see here. We will go back now to the next item. So we're done with content syllabus, class schedule. Class grades. Now that's important, right? Everybody's interested in that. The short version is that the class grades are going to be done on the 4-point scale. Right, so I'm not going to be averaging raw scores out of 100 or doing arithmetic, adding or averaging or whatever, raw scores on what I call the 100-point scale. Everything gets converted to the 4-point scale, and then we're going to do a weighted average of all graded items on the 4-point scale. So let's go back to the website here. And you can see I have a page for this as well, class grades. And these are the weights that we'll be using for these graded items. You see we have the 3 midterms. They're approximately 30% apiece, but I like to kind of ramp up a little bit. I don't want that first exam to hit too hard. Comes so early in the term, so it's a little bit less. And then they sort of slowly ramp up. You'll notice there's no final exam. I don't think final exams in the summer really quite work as well as they do during the semester. Summers are just so fast. In some sense, why take a final when you just took a midterm on that same stuff like very recently? It seems like a kind of duplication. Do notice that homework does count. 7% doesn't sound like much, but it can make a very significant difference. And do notice as well that attendance counts. And we'll say more about that in a few minutes as well. And again, not very much, but this can make a significant difference. And more to say about all of that. Please make sure to read all these details. Here's some, why is that not taking? It's not, I think my stylus ran out of battery there. There we go. This is a discussion of how homework grading goes, and this is a discussion of how attendance grading goes. Okay. All right. Okay. The midterm exams are all going to be graded on a scale, and it's currently not prepared because I don't have any exam curves yet. But I'm going to show you how the exam curves are going to work by going to my recent spring class website and clicking on that one. And so this is just a for example. This is not related to our course in particular, but it's going to be structured pretty much just like this. After every exam, I'll publish the curve, and you can see, so for example, on exam 2, if a student scores 80 out of 100, and that will translate as kind of an A+, right? That's a 4.10. That was a very hard exam. That was quite a hard exam. And so the curve was correspondingly, adjusted. Whereas, let's take exam 3, an 80, same raw score. Well, that exam wasn't as hard. An 80 on an easier exam is not as impressive as an 80 on a super hard exam. And as it turned out on this exam 3, an 80 translated to a 3.6, which is sort of an A minus, kind of approximately in some sense. Depends on how you count. Okay. All right. So these numbers, the numbers on the 4-point scale, those are the numbers that will be averaged in the weighted average, not the raw score. Okay. All right. Okay. Let's see here. So back to our web page. Let me also go to the course website. On the course website, email address, link back to the class website. But anyway, you'll notice course grades right here. So this applies to all sections of the course, which, again, this term, just us. But additional details, and in particular, this table here tells you, when you've computed your weighted average, how does your weighted average, that's going to be a number somewhere between 0 and 4.3, how does that translate into a course grade? And so the idea is that, roughly speaking, I round to the nearest sort of standard value. So if you have a 3.16, let's just say 3.16, well, that falls into this bin, right? And roughly speaking, the point is 3.16 is a little bit closer to 3.3 than it is to 3.0, which would have been a B, right? So 3.15 is kind of the cutoff between, are you closer to the B plus or are you closer to the B? So anything in this range translates to a B plus. So this nearest standard value perspective explains most of this. Do notice that this number is a little lower than you would expect. One might expect this to be 3.85. I lower it to 3.8 because of a phenomenon of statistics that when you average distributions, the distributions tend to narrow a little bit, especially at the extremes. And so all of these numbers, all of these bins, I came to as a conclusion based on an analysis with just a tremendous amount of real data. I took actual student grades on actual exams and combined them in the ways that I'm describing here, and hundreds and hundreds. And these bins are the result. What I think makes the most sense and what behaves most naturally with respect to that. Okay. All right. Let's see here. A few other things here. In particular, if you're taking the course on an SU basis, make sure to read all of that. Very important. And let's see here. By the way, I should have my thing charging. Sorry, a momentary pause here. Sorry for the delay. So make sure to read all this if you're thinking about taking this course SU. There are some important considerations there. Some other notes about how course grading is done. Again, you can just make sure to read all this, but again, it's all very important. Okay. By the way, I guess the last thing I'll say about grades, if you're not sure you understand what I'm talking about here, come talk to me. I'll be very happy to explain this in more detail. We can crank through some hypotheticals, talk about specific worries that you might have or what have you. But come on and talk to me. I'll be very happy. I want to make sure everybody understands. I think ultimately the course grading system, once you understand it, I think it's actually very natural, very simple. But we want to make sure everybody actually gets to the point where you truly, unambiguously understand it. So come on in and talk to me at your leisure if you're not sure how this system works. Okay, let's see here. Back to the list. Let's see here. So we did syllabus, schedule, grades. Okay, moving along. Let's talk about the YouTube recordings. So I video record every class that I teach, technology permitting. Every so often my computer will glitch or the projector blows a bulb or something is rare, but it happens sometimes. So, practical purposes, yeah, I'm planning to record everything. And I cannot emphasize this enough. I really urge you to make heavy use of these recordings. It's really important. Math comes at you really fast. And this class, I've already commented, this class is packed with material. And we're going to be covering it at a fast speed. And especially given that this is a summer course and we're going at, nearly triple pace, right? So I am very well aware that students are probably not going to have absolutely mastered glass smooth proficiency with all the material as you walk out of the classroom. That's not realistic. It's just not realistic. So when you leave class, going to the YouTube channel, finding the recording, I'll post them as soon as I can after class is over. And then they got to process, blah, blah. It usually takes a few hours. But you can go back to the recordings, and you don't have to listen to the whole thing again, but you can go to particular places where maybe you got stuck or something and listen to it again. It legitimately might make more sense the second time through. And then if, as you're listening to it again, you still don't get it, you might pause the recording and ask yourself, okay, what about this am I not getting? And maybe there's some prerequisite topic that you might have to confess to yourself. Yeah, you know what? That's the part that I don't get, that he's assuming that I don't get. And then you go back and learn some of that, right? Maybe watch some of those older recordings, appropriate to what you might be missing. And once you got that straightened out, listen to it again, and it again might make more sense after firming up those foundations. Okay. All right. So a specific bit of advice that I have for that is to annotate the lecture notes. Now, here's a copy of my lecture notes, and I'm on the first page. Let me just go forward just to let's get to something. So let's suppose, while we're talking about equations for planes, that you don't understand this reasoning here, right? Let's say you have a problem. Okay, how is it that we get from, let's see here. How do we get from there to there? And you're not sure, right? Okay, here's what you do. This is the move I like anyway. The student showed me this idea, by the way. I thought this was very clever. Look down here at the bottom right corner. You can see my little computer clock is there, and it says it's currently 4:46. All right, so what you do is you just write down 4:46, and maybe go ahead and put the date on there, May 9, right? So you just go ahead and jot that down, and then some later time when you want to come back and figure out how all that works, and you just want to go right to exactly this moment in the lecture, then as you go through the recording, just keep your eye on this thing down here and just keep fast forwarding until this gets to 4:46, and boom, you're back. Okay, so I think that's very efficient. I strongly encourage doing this sort of thing, as during lectures, right? As we're going through lectures, have the lecture notes up on your computer screen, and be prepared to annotate, using whatever software you prefer. And do like so. I think it's really good. And of course, you can also annotate with other, whatever else you want to say about it. You could, put a little note here that says, because of the, whatever. Just, jot little notes to yourself, whatever you want to do. Okay. All right. So I hope you will do that sort of thing. Let's see here. How do you get to the YouTube recordings? You may ask. Well, they're on the class website. Scroll down to the bottom right here. You can see YouTube recordings. And when you click on YouTube recordings, you go to the playlists section. And currently I don't have any summer recordings yet, but right here on the top left, depending on how you have them sorted, of course, but there will be a Math 219 2025 Summer 1 playlist. And then you just click on where it says View Full Playlist. Y'all know how to use YouTube. Why am I explaining that to you? That's silly. But anyway, you're going to see this recording that you're currently watching. That'll be listed first. And then all the recordings that I will have made by that time will just be listed right here next. Okay. Usually beginning with the date. Okay. All righty. Okay, let's see. Oh, yeah, and where, you might ask, do you get the lecture notes? Where's this PDF file that has all the lecture notes for the course? And by the way, it's 222 pages of lecture notes for the course. And again, no problem. It's on the class website here. There's a section here called Class Materials. You just click on Class Materials, and there it is right there. You can click on that, download that PDF file. And then I'll also note organizational notes down here. That is this document here that we're currently going through. Okay, so if you want to, download a copy of this, very convenient right there. These other files I'll be using as supplements during the lecture, various points during the course. So ignore them for now. Okay. Alrighty, moving along. So let's talk about some big ideas now. So the learning goals for the course, and arguably the goal is to learn multivariable calculus. I mean, that's what the course is called. So what's to discuss here? Well, there's understanding, and then there's understanding. And lots of students have the wrong idea about, what the right kind of understanding is for a course like this. And I like to have things boiled down in a pithy, succinct way. And so here's the way I like to say this. This is a course about ideas. It's not a course about answers. Whether you have the right answer at the bottom of the page is not the point, right? Whether I get the right answer or an arithmetic mistake, something like that, it's really not the point, right? What this course is about is ideas, not answers. Okay, said differently, related point, but different angle on it. This is a course about reasoning, right? Mathematical reasoning. We want you to understand how mathematicians think. Why are things true? Not that they are true. Why are they true? We want you to get it, right? We want you to understand deeply and significantly. So it is not good enough to just know what the formula is or what the theorem says. Okay, sure, you need to know that too. You do have to know the formulas. You do have to know the theorems. You do have to be proficient with the algorithms, right? But that's not really, that's just straight up not enough, right? So this is a commonly misunderstood thing. And I blame, let's just say high schools. It is complicated. And of course, how high schools teach math is complicated by the fact that they have a different category of students, and is understandable, and it's a difficult problem. So, there's all that. But this, high schools very often focus on students knowing the formula and rehearsing the algorithm and being able to plug and chug. And it's just not real mathematical understanding. It's just not what it is. So anyway, make sure you're clear on this point, that we're interested in this course. We are interested in ideas and reasoning. That's the big stuff. And you're going to notice this very heavily. It's going to be very difficult to avoid noticing this in the lectures. That's basically all I'm going to do in the lectures, is talk about ideas. That's the good stuff. That's what you need me for. Right? Y'all can rehearse algorithms on your own. You can memorize formulas on your own. But what I can do for you, what I can help with, is helping you understand ideas and reasoning. So I like to also point out, naturally, don't be surprised. It's also what you're going to find on the exams. The exams are going to be my attempt to gauge how much you understand the ideas and the reasoning of the course. Now, it's not going to be, paragraph style questions, right? The questions are going to be computations, but they're going to be computations that if all you've done is memorize some algorithms, you won't know where to start the algorithm. You won't necessarily know which algorithm to apply, right? And so I'm going to arrange the questions so that this is, again, I'm just doing my job, right? My job is to teach the ideas and the reasoning and then assess to what extent do you understand the ideas and the reasoning. And so the exams will accordingly be an attempt to measure your understanding of ideas and reasoning. So what I'm going to call creative application is going to be a big thing that you're going to have to do on exams. Is not just, again, plug and chug, but the way you'll solve the problem is by understanding what the question is asking, comparing that with the various conceptual tools that you have and the ideas that you understand. And when you see it from the right point of view, then realize, hey, here's a mathematical tool from class that, golly, I think that's going to totally solve this problem, right? And again, that comes from understanding, and it's not a plug and chug. There will be a subsequent plug and chug, right? But but the initial analysis is not plug and chug. Okay, so that's what the course is about. This is what the lectures are going to be. This is what the exams are going to test. And so therefore, this is what you should learn, right? You should focus on this if you want to prepare for the exams, right? If you want to get the most out of lectures, right? Then as you learn, keep all this stuff in mind. Keep in mind, you want to focus on ideas and reasoning. And, you got to know the formulas too, and you got to know the algorithms too, and blah, blah, blah. But don't forget that it's mostly about ideas and reasoning. So as you work on homework assignments, think about the ideas and the reasoning. Why was this exercise assigned? What ideas am I supposed to have learned? What ideas did I use to solve this problem? What other kinds of problems would I be able to solve with similar ideas? What about this problem makes it susceptible to being solved by these ideas? Think about the ideas and the reasoning, right? Okay. And then last point on this note is, when you're doing the exams, keep in mind what we're testing for, right? We're interested in ideas and reasoning. I know I'm repetitious. So that's where points come from. Can't emphasize this enough. It's not about whether you have the right answer at the bottom of the page. It's just not. That's not what this course is. We're going to be looking for the validity of your reasoning, the completeness of your reasoning, clarity of thought, and clarity of written communication, right? This is what we're going to be looking for. So you got to explain your reasoning. Again, that's what this course is about. Okay. All right, enough of that. All right. Okay, so let's see here. Another big, deep thought thing that we want to talk about is the learning strategy for the course. So, a lot of classes, lower level classes, high school classes, whatever the case may be, learning happens pretty much in the classroom, and that's a nice luxury when that's possible. Well, that's great. You show up, you listen, you participate, and then when you walk out, you understand, and that's how you learn. That's a real luxury, and it's just not feasible in, I'm going to say, most college math classes. There's just not enough class meeting time for that. So, this is a nasty problem. How do you use insufficient class meeting time to help students to learn too much material, you might say? And so the big idea is that you will do a lot of the learning outside of class. quite a bit of the learning happens outside of class. And so now there are exact details of this, how exactly do you, how exactly do you do this? On the course website, there's a section called How to Do Well in This Course. Let me click over to that. Here's the class website, and you, again, right here at the top, click course website. Here you go, How to Do Well in This Course. Right, and there's several things to say about it. And now this stylus is getting low on charge. Okay. But here is a page called Learning Expectations. This is a mathematics department document of exactly what are we interested in these math classes. And here is my documentation for this class in particular. Ideas and reasoning. Again, cannot emphasize this enough. And yes, of course, you will also have to know some formulas and be proficient with algorithms. But that's not what the course is about. Okay. And then lots of discussion about this kind of stuff. Right? So, I like this one here in particular. Why? Why can't I just know the formulas and rehearse the algorithms? And so there's a bunch of discussion here. And the short answer is, it's kind of similar to the reason of why you can't just be proficient with arithmetic, is because we have machines to do that now. Right? I mean, if you were really, 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 really good at arithmetic, that used to be a valuable skill. We needed people, 100 years ago, whatever, who were really good at arithmetic because, man, we have a lot of computations to do. How else are we going to do them? Nowadays, that's non-existent, right? We have calculators and computers. Well, increasingly, right? I mean, I don't know how much y'all were aware in your younger days, but it used to be that there was this thing called Wolfram Alpha that was very impressive because you could type math problems into it, and it would actually solve. You type in something like this, and it would actually do the integral for you. That's pretty good. And at this point, it's so much better than that, right? Of course, AI is a big buzz that everyone's talking about, and long discussion ensues. But if all you can do is regurgitate facts and formulas and execute rehearsed algorithms, then you're just a slow, unreliable, and expensive alternative to a, cheap, almost free internet service. Right? So, what you can offer to future employers, right? The fact that you can do arithmetic is come on, they don't want to talk about that. The fact that you can, crank out certain algorithms, they don't care. Right? That. What else you got? Right? They've got that for free. What else you got? And what you can offer that makes you necessary, that helps you contribute, that makes you valuable, that makes them want to hire you or admit you into their graduate program is understanding. That's what the computer still can't do. And I'm pessimistic on how much that's going to progress. Yeah, future is unclear. We'll see what happens, but anyway, so that's one of the big reasons there. So anyway, for your consideration, make sure to read all of this. There's a bunch of good discussions here. There's another nice discussion down here about how much time okay, it's yelling at me again. But how much time is it going to take you? A note in particular down here, a little addendum for summer students. I want you to realize that this is probably basically a full-time commitment to take this course. Because class meetings and study time and doing the homework, etc. I mean, it adds up. And keeping in mind that this is a hard class during semesters, and then you got to multiply by 2.5 because we're doing 15 weeks of material in 6 weeks. Okay, so blindingly fast. Keep that in mind. Okay, so that's learning expectations. Course design and strategy. This is the learning strategy that I was alluding to previously. How you're going to learn this material. Again, you're not just going to show up and listen and leave and call it a day. right? You can get more out of the course. You can get more out of the lecture if you preview the material before class. If you kind of know, not the whole story, obviously, right? If you could just read a book and be done, you wouldn't need to take the class. But you can read the book, read the notes, and kind of have a kind of rough idea. Not exactly, but maybe have a glimpse, have some reasonable sort of, okay, I see ballpark what we're going to be talking about. You will get so much more out of class if you do that. Then, step 2, obviously, come to class. Hopefully that'll help. I like to think so. And then after that, again, I don't expect you to have digested and perfected all of it right there during class, right? So you've got much more work to do after class. And we talked about some of that. So, you want to read the notes, read the book, rewatch some of the lecture recordings to the extent you can. Yeah, so lecture notes, the book, etc. And this, roughly this 3-step process is what I'm going to assume that you're going to be doing. And then just, full disclosure, because I will assume that you are doing this, right, I will make my decisions of what am I going to do in class on the basis of that assumption, right? So if you don't follow this procedure, not only will you not get the benefits of whatever it is you skipped, but you will get less out of the class meetings than you should, in addition to not getting the benefits of the before and the after. So it really is really important. So make sure to realize it is critical to learning in this course that you follow this plan. Always come to class kind of knowing roughly what's going to happen. Already proficient with the material from the previous lecture, right? Or at least, mostly proficient with the material from the previous lecture. Again, I'm going to assume that you're proficient with that previous material. And then after class, again, really hit it hard and aim for understanding everything after class. Okay, more to read here. Make sure to read all that. And then course resources. This is y'all going to read most of this yourselves, but for sort of dramatic purposes, I list you yourself as your primary resource, right? You are the most important resource you have. You are going to have to be responsible for learning the material, right? So you can come and ask me for help, right? And I love it when students come to office hours. Office hours are fun. I wish I had more time for office hours. Don't hesitate. Come on into office hours. Happy to help. I can't make you come, right? So you have to be your own initiative. I'm not going to force you. I'm not going to seek you out, right? You've got to take the initiative. Oh, here it is. I even wrote that down. Have a good plan. Make sure that you're learning appropriately. Seek help when you need it. If something's going wrong and you feel like the course isn't going well, again, you've got to take the initiative to come and talk to me about, hey, I don't think this is going right. Can you help me come up with a better plan? Happy to help, but you've got to come to me. Okay. And then blah, blah, blah. I will point out, let's see, unfortunately you'll notice all this is crossed out, the help room. We don't have a help room operating, but we do have TAs, and I'm expecting at least one TA to have some office hours, so don't forget about that resource. It's kind of taking the place of help room. Don't forget about classmates. I am a big believer in study groups. I learned so much from my study buddies when I was a college student. In some classes, I feel like I learned more from my study buddies than I did from my instructors. But that's incidental specifics in those stories. But anyway, it's a very, very good way to learn, and I'm a big fan. And make sure to have those opportunities. Past exams, all of my past exams. All of my past exams from this course, Math 219. And from the very similar Math 212, And then also the similar but a little different previous summer offerings that I did years ago when I was teaching Math 212. I taught out of a different textbook, and it's a little bit different. So there's 3 collections here of old exams with solutions. And I think that's a nice bit of study material. But I do give a warning here. Do make sure to be very careful with this warning. Oh gosh, it's really unhappy with there. Maybe this one's charged back up by now. Yeah, okay, we're back in business. Some students use past exams as pretty much the only way they study. And this is a mistake. This is not a good idea. It doesn't work. It's something. It's like I say, I think it's a good secondary study tool, right? But it really shouldn't be. I think it's a tragic mistake to make the past exams your primary study tool. And some discussion ensues. Make sure to read that. Don't forget about the Academic Resource Center. The Study Connect program, I think, is awesome. It's a great way to find a study group if you need one. All you got to do is sign up. Then they'll just email you with, hey, here's some other people looking for a study group. Fabulous little system they have there. Anyway, make sure to read all of this stuff. The course resources, and then again, don't forget to come to office hours. So my office hours are going to be pretty much right after class. Our class ends at 12:15. I'm going to, wrap it up in the classroom. Maybe go get a sip of water, use the restroom. Boom, 12:30. We're doing office hours. I wrote this wrong. I wrote this is a typo. It's not to 1:45. I'm sorry. That's a typo. How did I mess that up? Anyway, at 12:30 to 1 is what the office hours are going to be. So I'll get that fixed. And we will have, again, I'm hopeful, some TA office hours as well. Okay. Alrighty. Okay, a bunch of stuff about that. Let's see. Back to the notes. We're mostly done here. Make sure to read those, that discussion there. Just a couple of quick ideas here. This one helped me a lot when I was y'all's age. Maintaining a list of questions. I think this is a really cool idea. You're going to find that as we go through this course, as you learn a lot of material, there's going to be things that just nagging little, but I still don't get this one point. It keeps coming up, that kind of thing. Any sort of problem that you have, gap in your understanding, write it down. You have a list where you write down such things. And then when you come to office hours or talk to friends or whatever, once you get to the point that you feel like you understand it, then you just cross it out. Right? And so this will help you get more organized with your learning. And so you won't forget to look something up, or you won't forget to ask when you come to office hours. So I think it's an easy little trick. Lists, of course, when I went to college, there was no internet. There certainly weren't any smartphones. Y'all probably have better ways to maintain lists, but I did it on a piece of paper. Anyway, and it works. You'd be surprised. Sometimes a piece of paper is hard to beat. But anyway, whatever system you want to use. The course resources we just talked about, right? There's a bunch of them. Don't sleep on those resources. These could be really, really useful. Now, you don't necessarily have to use all of them, but think about all of them, right? And be open-minded to what might be useful, and maybe investigate all the options. Okay. Again, study groups, we already talked about that. I'm a big believer. Try to create dialogue. So I think this is a great way to learn. Don't just do like, hey, did you get number 12? How do you do number 12? That's not really the point. The point is, what's really awesome, my experience, is to say things like, okay, well, look, I feel like double integrals can be used to compute any quantity in 2 dimensions. I mean, just kind of throw a statement out there, which may be true, may be false. By the way, what I just said is false. But if you throw that out there, and then your study group can discuss, and someone might come up with a nice little counterexample, right? Of here's a 2-dimensional, here's a quantity in 2 dimensions anyway that you can't compute with a double integral. And anyway, creating a dialogue, get a back and forth. An argument is a fabulous way to get ideas bouncing around. And whoever's right has this unfair advantage in the argument, right? It's a totally unfair advantage to be right. And so whoever's right is likely to win the argument. And, good-natured argument. Keep it civil, obviously, right? But whoever wins the argument might have the right idea. Very likely has the right idea. So dialogue and discussions and back and forth, really great way to learn. Okay, and then let's see. I guess the last thing I'll say, I think I've hit everything I need to do. But when you're doing the homework, again, keep in mind the purpose of the homework is not to demonstrate what you understand. The homework is not an assessment. Primarily, we make it work. We make it worth 7% of the course grade, largely just to make sure students actually do it. But it's not intended to be an assessment. Primarily, it's intended to be a part of the learning process. Right? It's practice to force you into situations where you'll have to recognize what maybe you don't understand, so that you'll have to seek out that understanding to finish the problem, and therefore you will have learned something. And of course, it's also practice with execution and proficiency, and being able to get things done in a efficient and timely way, reliably, etc. So the point is, homework is practice. This is how you do well on the exams. The homework you should view as part of your process for studying for the exams. So don't just do the bare minimum on the homework. View it as an opportunity to practice the skill of written communication of math. And let me come back up here and remind you. Clarity of written communication. Right? This is part of what we're interested in. This is part of, how points are awarded. Right? So it's a non-trivial skill, and it requires practice, and homework is one of the ways that you will get that practice. So show your work, and likewise explain your reasoning. You're going to find it hard, a little bit challenging. How do I put this into words? How do I say this? That's good. That shows you that that's something you need to get better at, and the process of doing it, you will get better at it. So keep this mindset when you're doing the homework. Don't think of the homework as something to get done. Think of homework as an opportunity to practice. And of course, it's also a small part of your grade. And so, sure, there's, 7% is significant. And so, yes, you also want to think about that. Okay. All right. So that's everything on my list. I think we're done here. I hope the recording took. I don't want to have to record this whole thing again. I look forward to seeing you all in class on Wednesday, if I remember correctly. Let's see here. Whatever the schedule says. Wednesday. So see you then. And I hope everybody has a good weekend. And I look forward to working with you in Math 219. All right. Bye-bye.